Okay, so here is eViews. You can see this is the eViews software, and in this software there are four variables. One is x1, x2, x3, and y. And here are 8 observations, 1 to 8. So there are four variables, x1, x2, x3, and y. So what I am doing, I'd like to open all the variables as a group. So I click on the as a group. All the variables has opened. You can see observations, x1, x2, x3, and y. So these are the variables are here. You can see these are the observations, these are the observations, these are the data, these are the observation. What you can do, you can put it in eView so that you can also follow me. So what you do, you create all these variables and then you can follow me. Okay, what is my task? My task actually here is to draw a regression model. Here we shall be developing a regression model, and here y will be dependent variable, and x1, x2, and x3 will be independent variables. That we want to do here. Okay, but there are some guidelines. From here we can say what are the guidelines. I'm showing those guidelines. You can see from here the guidelines are okay. That so it is the regression model too that we want to develop now. Okay, here are some guidelines that we can talk about. When a variable is significant, a variable is significant when the p-value, when the probability value is less than 5%, then we say that particular variable is significant to explain dependent variables. But if the p-value is more than 5%, then that variable is not significant. I'm saying again, when the p-value is less than or equal to 5%, then the independent variable is significant to influence the dependent variable. So that is the guideline. Okay, and also guideline for of rejecting null hypothesis. The same story. When the p-value is equal to or less than 5%, reject null hypothesis and accept alternative. And if p-value is more than 5%, then accept null hypothesis. Okay, so what is the gist of it? The gist of it is when the p-value is less than 5%, that particular variable is significant, and when the p-value is more than 5%, then that particular variable is not significant to explain the dependent variables. So that is the guideline we follow. One is more than 5%, one is less than 5%. Okay, then the second issue, what are the features of a good regression models? They are the features. So you can see feature number 1, regression line must be fitted to data strongly. So that means the data must be fitted strongly, or the model must be fitted strongly. So this one is a feature of a good regression model. And second feature is that I said here, most of the independent variables should be significant to explain dependent variables. So that is the feature number 1. Feature number 2, and this thing can be tested using t-test. And feature number 3, that is here, independent variables should be jointly significant to influence the dependent variable, and this thing can be checked using f-test. Feature number 4, that residuals are not autocorrelated. So that is the feature number 4. In this regard, what is the null hypothesis? Residuals are not autocorrelated. What is alternative? Residuals are autocorrelated. And what test? The test is Bush-Godfrey serial correlation test that can tell that whether the residuals are autocorrelated or not. But here, the null hypothesis says that residuals are not autocorrelated, meaning that null hypothesis is desirable. So that means if the p-value is more than 5%, meaning that we cannot reject null, meaning that residuals are not autocorrelated. Feature number 5, variance of the residual is homoscedastic. So here, what is the null hypothesis? Variance of residual is homoscedastic. And what is alternative? Variance of residual is heteroscedastic. So here the null hypothesis is desirable. That means if the p-value is more than 5%, meaning that we cannot reject null, we accept null, meaning that that is desirable. And this thing can be tested using Bush-Godfrey test. So that is the feature number 5. Feature number 6 is what? Residuals follow normal distributions. So what is the null? Null is residual follow normal distributions. An alternative, residuals are not normally distributed. So out of these two, the null hypothesis is desirable. And the test is what? Jarkavera statistics. This one is a test that we shall be using to check whether residuals follow normal distribution or not. And here, if the probability value is more than 5%, then we cannot reject null. So that is desirable. But if the probability value or p-value is less than 5%, meaning that we can reject null, meaning that we accept alternative hypothesis. So meaning that residuals are not normally distributed. So that is not desirable. Okay, what I do now, So we can run our regression model, and, and that we can do now to check. We run the model to check whether feature number 1, feature number 2, feature number 3, feature number 4, and feature number 5, and feature number 6 are fulfilled or not. That we want to check now. Okay, so I am checking now one by one. So I minimize it, and this is my data. So what you can do, you can copy it, and then you can insert the data in the eView, and you can follow me. And as I told, y is dependent, x1, x2, x3 are independent. So now I run the model. I go to quick as before. I click on the quick. Then I choose estimate equation. What does mean by equation here? Equation means regression line or regression model. I click on it. Okay. Then always I put the dependent variable first. I put it. Then I put the constant. What is called constant? Constant is the intercept of the regression model. Then I put 3 variables. Those are independent, x1, x2, and x3. So here you can see y is dependent, x1, x2, and x3 are independent variables. And here I am using least square method, that you can see, and sample size is 1 to 8. That means total sample size is total 8. Okay, so what I do, I click on the OK to estimate my model. Okay, so this is the outcome of the regression model, and you can see the dependent variable, which is y, and here c is the constant, and x1, x2, x3 are independent variables. Okay, suppose what does mean by this for x1? It is the coefficient of x1, right? And it is the standard error of x1, and it is the t statistics. What does it mean, t statistics? Right? Okay, how to get this t statistics? This divided by this, you can get it all the time. Suppose I take about this one, x3. The coefficient of x3 is this one, and the corresponding standard error this one. So this divide by this, you can get this one. Okay, now you can see the p value or the probability value. These are the all p values are here, right? And these are the t values. But normally what happens, t statistics and probability always has opposite directions. That means if the t value, t statistics goes up, probability goes down, or if the t statistics goes down, probability or p value goes up all the time. But make sure, here I am talking about absolute value. Absolute value means there will be no negative sign. There will be no negative sign. So all are positive. So that is called absolute value. Okay, that we can see from here. Suppose this one, t statistics is very big. but you can see P is very small because there exist opposite directions. Okay, talk about this one. For this one, the P value is so big, 91.59%. But you see the absolute T value is very small. Right? Absolute T value means you ignore the sign. Right? So we can see there exists a opposite association between T statistics and probability. Okay, so and now whether x1 is significant, x2 is significant, and x3 is significant to explain why, that we shall be checking gradually, not now. Okay, what I do, then R square is here. How much R square? 78.04%. And F statistics is here, and the corresponding P value is here. So these are the important information about these models. So first I start one by one. Okay, first I talk about our feature of a good regression model. That I talk first. Okay. As I said, features of a good regression model. What is the feature number one? The regression line must be fitted to data strongly. That is the feature number one. Okay. So when the data will be fitted strongly, when the value of R square is more than 60%. When the value of R square is normally, we say normally more than 60%, then we say that regression line is fitted to data strongly. That we say normally. So now we check how much is the value here. Sorry, camera plus. So we check now how much is our value for these models that we have. Coming up just one more. Okay, so here the value of R squared is how much? 78.04%, meaning that it is more than 60%. So we can say that the data of this regression model is fitted strongly, or we can say that the whole model is fitted strongly because the R square value is more than 60%. So the feature number one is fulfilled. Then what about the feature number two? That we can discuss now. Okay, feature number two. Most of the independent variables should be individually significant to explain dependent variables. Most of the independent variables should be individually significant, and to check it we shall be using t-test. Okay, now we can check this part. How to check? We minimize the okay, now this is one variable and the p-value. So what is the p-value for these independent variables? Because as I told that Most of the independent variables should be significant, meaning that out of these three, at least two should be significant. Two should be significant uh, to, to make a good regression model. But we check one by one. First x1. How much is the p-value? P-value is 1.99%, meaning that less than 5%, meaning that this variable x1 is a significant independent variable to influence our dependent variable, which is y. Now, what about x2? What is the probability value? 73.57%, meaning that more than 5%, meaning that x2 is not a significant variable to explain our dependent variables. What about x3? What is the p-value? 23.38%, meaning that more than 5%, meaning that x3 cannot influence y. Okay, out of these three independent variables, only x1 is significant and other two are not, meaning that this model is not good because only one significant out of three.